Alrighty. Hey guys, I wanted to make this video to kind of help you out when it comes to differential equations and trying to solve them. Okay, so I know a lot of you are going to be gone here in the next couple of days, so I wanted to give you a little bit of help, that way you didn't fall too far behind whenever you came back. Okay. So this first problem is actually the problem that we skipped in class today. It should be on page 606. Okay. So this is the one that I skipped. And so I kind of wanted to go through it on here so that you've seen it. If you run into a problem like this, you kind of know what to do. Okay. So it's solving differentials using an initial condition. Okay, so your first step is to cross multiply. Okay, get your x's on one side and your y's on the other. Okay, now whenever you cross multiply, you're going to end up with x squared dy is equal to y minus 1 dx. Okay, you have y's with dx's and x's with dy's, and so we don't want that. So what you're going to do is you're going to divide by x squared on both sides. And then you're going to divide by y minus 1 on both sides. Y minus 1. So you get 1 over y minus 1 dy is equal to 1 over x squared dx. Okay, y's are on one side, x's are on the other. Now we can integrate. Okay, so we're going to integrate both sides. Now, if you look at the y portion, you should recognize that you need to use u substitution for that. Okay, so I would set the u equal to y minus 1, which means that du is just dy. Okay, this is a fairly straightforward u substitution. Okay, so your integral is going to end up being 1 over u du. It's going to equal, and I'm going to rewrite the 1 over x squared as x to the negative second dx. Okay, so you should know that to integrate 1 over u, it's the natural log of the absolute value of u, which is going to equal, and then we integrate this, so we're going to add 1, so it's going to be x to the negative first over your new exponent plus c. Okay, so over here, we're going to have, there we go, okay. We're going to have the natural log of the absolute value. I'm going to replace u with y, so y minus 1 is going to equal negative 1 over x plus c. Okay, or you could leave it as x to the negative first. It doesn't matter. Okay, so now this is the general solution. We need to use the initial condition. Now remember what I said in class today. If you're dealing with natural logs and e's, use the initial condition before you get y by itself. Okay, otherwise you run into a big old mess. So I'm going to use this initial condition here. So the natural log, that should be an absolute value, of 0 minus 1 is equal to negative 1 over 2 plus c. Okay, so we have a natural log of 1. At that point, it's no longer absolute values, it's just, okay, is equal to negative 1/2 plus c. Okay, so you should know that the natural log of 1 is actually 0. Okay, but if you don't know that, type it into your calculator. Okay, just double check yourself. I still have to check myself on that. So we just add 1/2 to the other side, and that's what c equals. Okay, so now we have the natural log, the absolute value of y minus 1 is equal to negative 1 over x plus 1/2. Okay, we're not done. We have to get y by itself. So to get rid of that natural log, we have to raise everything to the e. Okay, so that's going to cancel out. We have the absolute value of y minus 1 is equal to e to the negative 1 over x plus 1/2. Okay, so remember, like I said today in class, to get rid of the absolute values, you have to make two separate equations. Okay, so I'm going to do 2 steps in one here. Okay, I'm going to split up my equation. So I'm going to either have y minus 1 is going to equal positive e to the negative 1 over x plus 1/2, or y minus 1 is going to equal negative e to the negative 1 over x plus 1/2. Okay. Now, if you're adding your exponents, it means you're multiplying the bases. Okay, so really, I can rewrite this, both of these, as e to the negative 1 over x times e to the 1/2. Okay, and over here it's going to be negative e to the negative 1 over x times e to the 1/2. Okay, so if you add 1 to both sides, and you have y is going to equal plus 1 or the negative of that. Okay, now double check with your initial condition to make sure that, or to figure out which one of these works. Okay, so if our initial condition when x is 2, y is 0, so 0 is going to equal e to the negative 1 over 2 times e to the 1/2 plus 1. Okay, eventually e to the negative 1/2 times e to the 1/2, look back here. You're adding them together. So what's negative 1/2 plus 1/2? Well, that's 0. Okay, so e to the 0 is always 1. So you're going to have 1 plus 1. Well, that does not work. Okay, so your particular solution is going to be this guy. Okay. Okay, this next problem, I didn't go through this in class. It's on page 608. I probably won't go through this one in class because it's not super relevant to what you guys need to know. But I did want to start it here just so in case you run into something like this, you kind of know what you're doing. Okay, so the acceleration of a particle moving along the x-axis at time t is given by a of t is equal to 6t minus 2. If the velocity is 25 when t equals 3 and the position is 10 when t equals 1, then the position x of t is equal to what? Okay, and you have all of those choices. So this technically is not your normal differential equation, but you're going to be using the same process. Okay, we have acceleration and we need to get to position, so we're actually going to integrate twice. Okay, so the first time is whenever you need to find v of t, okay, which is velocity, which is the integral of a of t dt. Now we don't have time intervals here. Okay, so it's going to be an indefinite integral. So if we integrate 6t minus 2 dt, well, that's going to be, okay, so t squared, you're going to divide 6 by 2, so you get 3t squared minus 2t plus c. That is your general velocity, okay? We have to use an initial condition to figure out what c is, and we have one. The velocity is 25 when t equals 3. Okay, use that to find your c. Okay, so you're going to have 25 is going to equal 3 times 3 squared minus 2 times 3 plus c. Okay, so 3 squared is 9 times 3 is 27. So 25 is going to equal 27 minus 6 plus c. So 25 is going to equal 21 plus c. Subtract. C should equal 4. So v of t is equal to 3t squared minus 2t plus 4. That is velocity, okay? We need position. So you're actually going to integrate velocity. So x of t is going to be the integral of your velocity. Okay? So let's see here. 3t squared minus 2t plus 4. Okay? If you think you can figure this out, go for it. Pause the video, see if you can do it, fast forward, and then check your answer. Okay? So, if I integrate that, it's going to be t cubed minus t squared plus 4t plus c. Okay? And again, use your initial condition. The position is 10 when t is 1. So x of t is going to equal 10, and we're going to plug in 1 for t. Okay? So 10 is going to equal, let's see, 1 minus 1 plus 4 plus c. Okay? So those will cancel, subtract 4, 6 should equal c, which means that x of t is equal to t cubed minus t squared plus 4t plus 6, okay, which ends up being c. The next problem I want to go over is on your homework. So if you look at page 610 in your homework, you get this funky looking thing. And I just want to go through number A, or letter A there. Okay? The reason I want to go through this is because I had a really hard time with this. And so if I had a hard time, you guys are going to die. Okay? So I want to break down the lingo of this. So it says, consider the differential equation dy dx is equal to 3 minus x over y. Let y equal f of x be the particular solution to the given differential equation for 1 is less than x, which is less than 5, such that the line y equals negative 2 is tangent to the graph of f. Find the x-coordinate of the point of tangency and determine whether f has a local minimum, local maximum, or neither at this point, and justify your answer. That is a lot of mumbo-jumbo, okay? That is a fancy way of saying find the critical point, okay? Now, how do I know that? Find the x-coordinate of the point of tangency. What do we know about the point of tangency? Well, that's pi, okay? We find the point of tangency by setting the derivative equal to 0, okay? So you're eventually going to set dy dx equal to 0. But dy dx has both an x and a y, okay? You can't solve an equation with two variables. Okay, that's why you know that the y coordinate is -2. So you're going to plug in -2 in for y and set it equal to 0. Again, if we set a fraction equal to 0, just the top should equal 0. So 0 is equal to 3 minus x, so x is going to equal 3. Okay, so your point of tangency is at 3, -2. Okay, you found the x coordinate. Now you have to determine whether it's a local minimum, maximum, or neither. Well, this we need a sign chart. Okay, so my sign chart is going to look at 3. Now I'm going to look at 0 and 4. Those are the points I'm going to pick. Okay, so if I plug in 0 into dy dx, okay, so 3 minus 0 over -2, is that going to be positive or negative? Well, that looks like it's going to be negative. Okay, over here, 3 minus 4 over -2, well, that's going to be a negative over a negative. Whoop, just going to equal positive. So if my slope is negative and then positive, that means I have a minimum. Okay, justify your answer. I cannot get that enough. Okay, you must justify your answer. How do you know that that point, 3, -2, is a minimum? So since dy dx changes from negative to positive at 3, -2, then that point is a minimum. Okay, so that's just to get you started on this one. Okay, if you run into a question that the lingo just kind of freaks you out, break it down. What's it asking for? Underline keywords. Okay, a lot of these questions, they're gonna have some funky wording. Okay, so if you have questions on the homework, be sure to let me know. Those of you guys that are going to be gone a lot, be sure to text me on Remind if you have questions, okay? We'll see you guys next time you're in class.